Every physics textbook says there's a hard ceiling on how much heat an object can radiate. It's called the blackbody limit. Scientists just smashed straight through it. Back in 1900, Max Planck calculated the absolute maximum for thermal radiation. For more than 100 years, it was treated as an unbreakable law of nature. But that law hides an assumption. The objects are far apart. Bring two surfaces within a few hundred nanometers, 1,000 times thinner than a hair, and the rules change. At that distance, heat doesn't just radiate across the gap, it tunnels. Electromagnetic fields that normally die at the surface reach across and carry energy directly. This is near-field radiative heat transfer, and it can beat the blackbody limit several times over. The catch? It only worked with exotic crystals, useless for real computer chips. Now a team from Carnegie Mellon, Stanford, and Purdue pulled it off with plain gold. They etched arrays of tiny split-ring resonators, metamaterials, onto two facing membranes. The gold structures and the material's own surface waves amplify each other, moving 4 times more heat than plain surfaces. And gold is already standard in chip fabrication. Future processors could dump heat across an empty gap with no contact at all, or turn waste heat straight back into electricity. Published in Nature, 2026.